So the inspiration for this particular video is a conversation I was having with somebody about websites and dead links and the problems that they can create. And because I work on websites as well, at work and otherwise, I decided, well, why download one when you can write your own? Hey everyone, Tim here, Silver Pascal Coder, and as indicated by the introduction, we're looking at a program or writing a program to look for dead links on a web page or website. So, where do we start? Well, initially I had a little tiny console program, and all it was really doing was to download a web page from a website, and it would use an HTTP client that comes with free Pascal, and obviously we need to include our open SSL units as well, because if we have a web page which uses HTTPS, then we need our program needs to be able to accommodate that, and not so that it can't open the SSL libraries. And then my thought was, well, what libraries exist in free Pascal which allow me to parse or process the contents of a web page. Pascal is old enough that I'm sure something would be out there. Well, I found this fast HTML parser, and that's what I'm using, and so I downloaded that, and it's in the same folder as my program, or a subfolder. And basically what it has is, let me see if we can go, not that one there, we go to this one here. It basically has two event handlers to call when it finds text or it finds a tag, and in order to use it, then you pass across a stream, and whenever it encounters text or a tag, one of these event handlers get called. Now, when you do this, though, you'll find that in my we're just going to here show you what the initial results are when I basically did this. Now you can see here that there's a lot of I don't want to say junk, but there's a lot of stuff here that I wasn't needing, but in order to work out what I needed, I wanted to see everything. So we know that we don't want to look at the text anymore, so we'll just build this again. If I can find the build menu, I'll be happy. And now we can see something of use, and we also know here that typically a link will be contained in an anchor tag, and we can see one here. So now what we want to look at is, well, okay, if it's we'll clean that up, and then we will get the value from the href element, and we're going to add that to a list of links that we find on the page. So ultimately what's going to happen here is that my little parser here will, when it finds an anchor tag, we extract the href element and drop that into a list. And so this particular class will be used somewhere else, and that's what we're going to be looking at next. Oh, and by the way, just before we go on, this little tiny class could be a record really, but is used to store a status code in relation to a link, which will basically be used in the calling routine, because at the end what we're going to be looking at is something like this nice little output. So now if we go into our next unit, which basically uses the page link class, and what it will do is it has a A scanning routine for a URL, and from that URL it's going to return a list of a list of links and whether they were and their status code. We're also using an HTTP client, and then to make things a little bit more, this was added, slightly as an afterthought because the program was, let's say, not performing as fast as I would have liked, and part of that was because if you've got multiple links to the same page, and because you've got maybe like a fragment afterwards, that's with if you have a hashtag and an ID. I don't need to check that page every time. So obviously then in our constructor here, we will create our client and our list of processed pages here. So to do that, what I'm doing is I'll make sure it's sorted to make our searching faster, and we'll make sure that there are no duplicates in it. Now, if we're going to create these in a constructor, then in our destructor, we also need to get rid of them. Now we're going to come to this check this link in a bit, but next function we're going to look at here is this scanning function. And as I said before, given a URL, let's get a list of the hrefs, and we'll then look at each of those and see whether they are a dead link or not. And that information gets put into here. So here what we're doing is we're going to download that web page. We will then, well here actually this is where we're downloading it. We then reset our position in the page stream. We can then parse, the downloaded page, and we've already looked at that code because that's all this one in here where we use the HTML parser here. And we have a set of links now. And so what we are then going to do is for each of these links, we're going to well, first of all, what we're going to need to do is normalize these links. Now, the reason why is because what you'll see here are relative paths being used, and we need to put something onto the front in order for us to download it. And so to do that, I've got this little normalize routine, and basically if I've already got an HTTP or HTTPS, then they're just going to be returned. Otherwise, we're going to use this function here, which is part of where is this function? Which is part of the URI parser. And what it will basically do is, given a base URL and a relative URL, it sort of like fixes it up so you have like a full path, and that enables something like this here to be converted into that. So we'll just go back to where we came from again, which was here, and then what we'll do is we will check or not whether we can just get the header for that particular page, and from there we will then add that to our own page list. So our list here will basically contain both a link with a fragment as well as a regular URL, and that gets returned to the caller. And that's now here, this little function here. Let's say when the program was initially running, or the first time I wrote this or created this function here, what it would basically do is to get that page, or try and retrieve the header of that page, and if it returned a fail, well, it failed, and we could then get the status code of that, and if it succeeded, then I'm going to say it's 200. But if I've got something like, let's see whether here, something like this where I've got a fragment being used, that's the value after the hashtag, there's no point in trying to get that page twice. So what I've done is I've added some code into let's say return or to have a list of processed pages, and if I've already processed that page, well, I'm just going to use that previous value rather than trying to get it a second time. And in order for that to work, we obviously need to add that base page to this processed list here. So I'm thinking, you know, that process list could have been, well, actually, the process list would actually be a subset because it's only going to be the base URL. So for something like this one here, so, you know, I'll only have one entry in my base list. Anyway, so just to summarize this particular function here, if we can find the base link, we will return that. Otherwise, we'll go off to the website, store that result in our process linked list, and do that for each of the links here in our program. So now we have both a scanner and something to retrieve, you know, just to extract the links from a page. We are now in a position where we can now use it here. This is our main project source here. So we have our scanner, which is what we just looked at, and then we've got our list of pages here that we're going to, you know, create a report on. And I'm just going to let it be the owner of anything that gets added to the list. So here what we're also doing is we're incorporating ideas from all the other videos that we've used to make something that's, you know, useful here. So once those two objects have been created, we can then run the scanner over the URL and drop it into a page list, the results. And then what we will do is then to write out that page list. Well, in this case here, we're going to go to the screen, and we should look at that function in a moment. And just finally to wrap that up, you know, basically pass something from the command line to that function there. The the dumping page list function, what it will do, all it will do is iterate through each item in the list, and then write out, you know, whether it was okay or whether it failed. And what we're also doing here though is outputting the number of bad links. Here we are initializing link failed in the declaration block, again, previous video. And then that gives us this result here. So what we're going to do now is I'm just going to remove some of the debugging code that we had put in previously. So I'm just going to, we're going to take out that one here, and are there any other ones? Downloading that page here. I'll get rid of that one and that one. Now we'll build this again. And let's just see what the results look like now. Okay, looks like I've taken out everything. And here is the final results after all of that. So where could we go from here? Because this only is really testing one page. Because now for me to have to, let's take this page here, we can see that there is actually a couple of dead links. Well, actually I should say here that my program here, this one here I think is a server denied type error, but that's why that one failed. But why can't we go to, maybe that one's the same. Yeah, so that's about it for this. That's about it for this particular video here. I hope I wasn't off screen too long. So what could we do from here? Well, firstly, we could make it into a program that could, you know, check all the links returned. The second thing we can do is to make it into a GUI app. There's potential of adding in a thread per page, for instance. These are things that either I can do next week or you can add in for yourself. I'll put the link into the description below once the code gets up to GitHub. And if you liked what you saw in this particular video here, Don't forget to hit that like button, subscribe. It just helps my channel out in YouTube for others to find it, because we all want Pascal, modern Pascal, free Pascal, Delphi even, to get more recognition. So on that note, happy coding, and I'll see you next time. Bye.